So the second type of problem you need to be able to do is rewriting a piecewise function given a new rule. So given that f of x is equal to x plus 3 if x is greater than 0 and 2x plus 3 if x is less than or equal to 0, it says write the rule for the new function. So write g of x if it's a horizontal shift of f of x 2 units to the left. That means if I were to take this piecewise function and if I move the entire thing to the left 2 times, 2 units, what would the new function look like? And that function is called g of x. So what happens if you go 2 to the left? That's a horizontal transformation, so something's going to be happening to the input, to the inside of the function. So what we have is g of x is really f of x, but since we're going 2 to the left, you have to do plus 2, right? Do you see how that's going left 2? And since this is a horizontal transformation, or notice that your input has changed, everywhere you used to see x, right? Everywhere you used to see x, both in the rule and in your domain, you're going to have to replace it with x plus 2. So again, your input has changed from x to x plus 2. And everywhere you see an x, you're going to replace it with x plus 2. Okay, so notice that everywhere I saw x, right, because it's a horizontal transformation, now I'm going to substitute with x plus 2. Right, everywhere I saw x, right, I'm going to substitute it with x plus 2. Whoops, I forgot to do that last one here. So this one right here should say x plus 2 is less than or equal to 0. Okay, there we go. Because your input has now changed to x plus 2. And for your final answer, all you have to do is simplify. So x plus 2 plus 3 would give you x plus 5 if isolate x by itself, so you get x is greater than negative 2. Distribute here, so you get 2x plus 4 plus 3, that would be 2x plus 7. If, again, isolate the x by itself, x is less than or equal to negative 2. So that is your final answer. So here's what you need to do. You need to rewrite in terms of f of x. So if it's a horizontal change, you're going to have stuff happening on the inside. If it's a vertical change, you're going to have stuff happening on the outside. And then if you have a horizontal change, your input has changed. So everywhere you saw x, you have to replace it with your new input. Simplify that, and there's your final answer there. Let's take a look at this example. Now you have to find the new rule for t of x, a reflection over the x-axis. So what would t of x look like in terms of f of x? Well, a reflection over the x-axis, that's a vertical reflection, so you're going to have stuff happening on the outside, right? Because it's your output that's changing. So you take your f of x and you would multiply it by a negative. That is a vertical reflection or reflection over the x-axis. So now what you're going to do is you're going to take f of x, which is what we have. So to all the y values or to all your outputs, you're going to make them opposite in sign by multiplying by a negative. Right, so you take your y and multiply by negative. Well, if you look at your piecewise function, you have y equals x plus 3 and y equals 2x plus 3. So you would take this portion and multiply by negative 1. Take this portion and multiply by negative 1. Your domain right here would not be affected because that has to do with your input, right? This is your output. Okay, so again, you are taking your output or your y value, multiplying by negative. So you would multiply whatever that whole thing you had, you're going to multiply by a negative. That y entire value, you're going to multiply by a negative. And again, you do not need to do anything with the domain because this only has to do with the input. And when you simplify your answer, you would get t of x equals negative f of x, which is negative x minus 3 if x is greater than 0, negative 2x minus 3 if x is less than or equal to 0. Okay, let's do 3 try problems. Given f of x is equal to x squared if x is less than or equal to 3, x minus 1 if x is greater than 3, write the rule for the new function. Okay, number 1 says to find g of x, a horizontal stretch of f of x by a factor of 2. So I see the word horizontal stretch. So I know that the g of x is going to have something happening on the inside. Anytime you have a horizontal transformation, like horizontal shrink or stretch, horizontal reflection, horizontal translation left and right, you're going to have stuff happening on the inside. Well, it's a stretch by a factor of 2, so when you have that factor, you know you're going to multiply by something. So if it's a horizontal stretch by a factor of 2, what number are you going to see on the inside? Is it going to be 2 or the reciprocal 1 over 2? Right, you're going to see 1 over 2 on the inside, because whatever number you see on the inside here, when you actually describe it using words, the factor is going to be the reciprocal. Okay, so again, the number that you actually see, take the reciprocal of that, and that's going to be your stretch or shrink factor. So you have to be able to go backwards. Because I see the word a horizontal stretch by a factor of 2, I'm going to flip that over and I multiply by 1/2 on the inside. Now I just have to rewrite my function now, right? Because this is like the hard part, knowing what to do, and then now I have to substitute. Because it's a horizontal transformation, that means my input has changed. So everywhere you see x, you're going to replace it with 1/2 x and then simplify. So here, right, I've replaced everywhere I see my original input of x with 1/2 x. And now I have to simplify. So be careful right here that you're squaring the entire term. So for your final answer, we get 1/2 squared x squared, so it's 1/4 x squared. If, get the x by itself and multiplying by 2 on both sides, x is less than or equal to 6, or 1/2 x minus 1 if x, right, if you multiply by 2, is greater than 6, and that's going to be your final answer. Go ahead and try this problem. Find r of x, a vertical translation of f of x 5 units up. So r of x is a vertical transformation, so you would take f of x and you're going to add 5. This means only the y values are affected. So you take whatever the output is and you're going to add it by 5. So again here, this is your domain, your input. It's not going to be affected since your new rule is that you take your y and add 5. So you're going to take your y and add 5 to it. Take your y and add 5 to it. Okay, so here I've added 5 to my y, right, to my output, and then when I've simplified, I get this as my final answer. Could you go straight from here to here? Absolutely. Just be careful that you're doing the correct computation right here. Okay, last problem. Find the rule of q of x, a reflection of f of x over the y-axis. So first step is to rewrite q of x in terms of f of x. The thing you have to be careful here is even though you see y, you might think that it's a vertical transformation, but it's not. Remember, when all the y values are, or when all the values are reflected over the y-axis, all your x values are being changed. So you're going to have f of negative times x. So it's actually a horizontal transformation. And when you have a horizontal transformation, meaning your input has changed, everywhere you see an x, because that used to be your original input, you're going to have to replace it with your new input. So everywhere I see x, I'm going to replace it with negative x. And be careful with the parentheses here, because that whole thing is going to get squared. And right here on the domain, do you remember what to do if you isolate the x by multiplying by or dividing by a negative sign? What happens when you multiply or divide by a negative sign? Right, the inequality symbol switches. So we would get positive x squared if x is greater than or equal to negative 3 when you multiply or divide by negative 1 there. Negative x minus 1 if, right, again, if you multiply or divide by that negative 1, you would swap the inequality sign and you would get negative 3 on the other side, right, because you're dividing or multiplying by negative. The signs would change and the symbol, inequality symbol, would flip. Here's your final answer.